Do planet orbits have perfect circles? Explained. Imagine watching planets dance around the sun, each moving in a smooth, predictable path. But do these paths form perfect circles, or is there more to the story? Most planets do not travel in perfect circles. Instead, their orbits are shaped like elongated ovals called ellipses. An ellipse is like a circle that has been gently stretched out, making it look more like an oval. This shape has two special points called foci. The sun sits at one of these foci, not at the center of the ellipse. The degree to which an orbit deviates from a perfect circle is called eccentricity. If the eccentricity is 0, the orbit is a perfect circle. But in reality, most planets have very low eccentricities, meaning their orbits are almost circular. For example, Earth's orbit has an eccentricity of about 0.0167, which is very close to 0. This makes Earth's path nearly a perfect circle. Mercury, the closest planet to the Sun, has a higher eccentricity of about 0.2056. This means Mercury's orbit is more elongated and less circular than Earth's. The variation in eccentricity among planets is due to gravitational influences from other planets and the history of how they formed. This elliptical shape was first described by Johannes Kepler in the early 1700s. Before that, many believed planets moved in perfect circles because circles were seen as the ideal shape. Kepler's laws showed that planets move in ellipses with the sun at one focus, explaining why planets sometimes move faster and sometimes slower during their orbit. Because of their elliptical orbits, planets sometimes come closer to the sun at a point called perihelion and sometimes move farther away at aphelion. This change in distance affects seasonal patterns and climate on planets like Earth. Understanding that planetary orbits are ellipses helps astronomers predict where planets will be at any given time. It also guides space agencies when planning spacecraft routes, as they need to account for these elliptical paths. So, while planets may seem to move in perfect circles from our view, their paths are actually slightly stretched out ellipses. This shape influences how planets travel around the sun and shapes the dynamics of our solar system.